Hello, everyone. Today, what we're going to look at is how to officially prove that two triangles are congruent. Now, that does mean we're jumping into our second round of proofs. And the nice thing about this round is, unlike the first one, it follows a very set pattern. But before we get into what that pattern is, let's talk about, in general, what is the point of a proof and why do we keep doing these in math? And just to look at it broadly, the point of a proof really is threefold for you guys. The first thing that proofs help with is they explain or show how you know your answer is right. Now, this is actually really important because a lot of times we jump to conclusions without even realizing it. So, for instance, I might look at two triangles and go, hey, those things look pretty similar. And I might say, you know what, not only do they look similar, they're pretty much identical. And if they're identical, then these angles would have to be congruent. Well, sometimes that works, and sometimes you might be right. But other times you might be wrong and you made a false conclusion. And even though it seems reasonable, even though it seems right, you don't have enough evidence to support it. And it's really easy to justify it in our own mind. When you are doing a proof, you're doing kind of your own fact checking. You're making sure that you have enough information to conclude what you want to conclude. And this is important not just for math, but for real life. If you're going to make a wild statement, make sure that you have something to back it up. It's not just some random fact you throw out there. And that brings us to the second thing. Doing this gives us skills, so it develops our skills. Develops our evaluating skills. And fact-checking. By doing this, what we're essentially doing is we're not only evaluating whether or not what we think is true, but we're also learning how to figure out if something is undoubtedly true, and that takes evidence, that takes support in the mathematical world, just like conclusions will take support in science and in history and in English. And the more you practice that and practice laying out truth in a way that's easy to follow and conclusions in a way that's easy to prove and disprove, the more you get better at evaluating when other people do that right. So you know better who to believe. Even if it doesn't look like this, it's building those skills. Same thing then for the last. The last kind of follows through with these ideas, and that is that it gives you organization. Basically, we are building the process of logical thinking. And even if you never have to do a proof in real life, the ability to follow those thought processes and find out how to organize it in a clear and easy to follow way is a skill that can really help you mentally. But even if you disagree with all three of those and you're like, no, it doesn't really do it, well, you're going to have to do this anyway. So let's find out what we need to do in order to prove our conclusions and practice these three skills. So last time I gave you guys a theorem sheet, and this time you have a new one. If you go on Classroom, you can find this, and that is the first sheet of our notes. Now, with this sheet, you guys, again, can use this on all tests, quizzes, and the exam. And for today, we are simply going to be using this section. This is, if you read through it, what we were working with on Friday. We want to prove that triangles are congruent, and we're going to be using SSS, ASA, SAS, AAS, and later on HL, which is hypotenuse leg. So don't worry about this one right now. That's why it has a little asterisk. Now, in order to figure out if these things are true, if they have three sides in common or angles and sides, what we use from pictures and givens are traditionally these three things, and this is what we used on Friday. We used what was marked. Those are our givens. So anytime an angle or side is marked as congruent to another, well, we know that that's a given. We also use vertical angles, which, don't forget, in a table, just like last time, is going to take 2 steps. You're going to need to state that angles are vertical, and then once you know they're vertical, the vertical angles theorem tells us, well, if angles are vertical, then they're congruent. So that will let us conclude that angles are congruent. And the reflexive property, which just says if you share a side or an angle, then the sides are congruent to itself, or the angle is congruent to itself. So we're going to use those 3 today to prove each of the following. We want to prove that these 2 triangles are congruent. Now, normally what I do first is I just check, hey, are they congruent? I look for things like the markings there, so I know I have angles congruent, and I know I have a side congruent. And what I want to find is as much other information as I can. Well, here I notice that these are vertical angles, and because they're vertical angles, they must be congruent. That means that currently I have 2 angles and a side not between the angles. So I have angle, angle, side, which is one of the currently 4 choices, angle, angle, side, for proving that triangles are congruent. So I could tell you right now, these triangles are congruent. But if I wanted to prove this without a shadow of a doubt, what I really need to do is show, first in my proof, this angle is congruent to this one. Second, my other angles are congruent. This angle is congruent to this angle. And third, that side is congruent. Then I'll be able to conclude, using the AAS triangle congruence theorem, that the 2 triangles are congruent. So let's lay that out formally. When I do this, I use the triangle congruence statement as my walkthrough. So I'm going to start with my first angle and prove that S is congruent to V. And that, of course, is given because it's a marking that I did not draw, but was given to me from the start. So I've proven the first angle. Now I need to prove the second angle. For this one, I want to say that the angle RTS is congruent to UTV. But I'm doing that because they're vertical angles. And when I look at my sheet, I notice that it's going to take 2 steps to do that. First, I have to say that the angles are vertical angles so that I can later on use the vertical angles theorem. So I'm going to start by saying RTS and UTV are vertical angles. And I'm going to abbreviate that just because I'm running out of room here. And that, remember, we can say is the definition of vertical angles, something we're allowed to conclude from a picture. And I also allow you guys to write for this one given, since it was something that is visibly seen in the picture. But notice how, since I haven't actually said that they're congruent to each other, I haven't actually finished the second angle yet. So I'm going to need a second line to say RTS is then congruent to UTV, the angles, and that is because of the vertical angles theorem. Which tells us that since we know they are vertical angles, they have to be congruent. So that takes care of my second angle. I have that statement. And that means I only need to prove that the side is congruent to the other side. So I'm going to say that RT, the side here, is congruent to UT, that side there. And again, since it has a marking that I didn't draw, that is a given. So finally, I can make my last statement. And notice that this was 1 box short, and that's because we're always kind of guessing how many steps these are going to take. And the final thing I want to do is actually prove this. So I actually want to say RST is congruent to triangle UVT. And that is according to, well, I use the AAS triangle congruence theorem. And I would be done. One thing to note with this is even though I did go in the order AAS, as long as all 3 of these are present, I could have started with the side, I could have then gone to this angle and then this angle, and that's totally fine, as long as all 3 of these take place before I use the angle, angle, side, which requires each one of those congruency statements. So your proof might look a little different than mine, but it should have all the same components. Now, another one that we did was one like this, where we said, okay, I have this triangle, EDF, and I also have the triangle GEF, this one over here. And I want to prove that those two are congruent. Well, currently, I know I have these two sides, this long DF congruent to this long GE. And notice how, since they share this third side, EF, that would also have to be congruent. That means I have 1, 2, 3 sides in common, which tells me that these triangles would have to be congruent according to SSS triangle congruence theorem. And that means that I now have enough information to know I can prove these are congruent, and I can prove it just by proving each of the sides are congruent. So let's start with our givens. I know that DF is congruent to GE. And I know that that has to be true because, well, it was marked and therefore it was given to me. The second side that I want to prove is, again, let's go with the easy ones. DE is going to be congruent to GF. And again, because it's marked and it's not drawn by me, that's a given. And I've proven the second one. That leads me to my third one. Now, the third one I drew in the marking, so I know I won't be writing given here. The reason why I knew that these would be congruent, EF congruent to FE, is because these two form the same line segment. In other words, it's the reflexive property. Something is congruent to itself. And since we have reflexive property of congruence, I can use that to justify the fact that these two sides are congruent. And it won't take me 2 steps in this case because I'm making that assumption based on simply looking at it. And it's one of the few things I can assume simply by looking at it. Same with vertical angles. I can assume that these are vertical angles simply by looking at it, right? So I can say this is a vertical angle to this, should I want to. I just don't need to here. And that would just be a given or definition of vertical angles because I looked at it. And I'm doing that same thing here, only because the reflexive property allows me to say they're congruent, I can jump right to my congruency statement and be done with that part. Now, I'm not done with my overall proof. Don't forget that what you need to always end with here is what you're trying to prove overall. And I want to prove that the triangles are congruent. Well, since all 3 sides are congruent, I know those triangles are going to be congruent. And I know because of the SSS triangle congruence theorem. Therefore, I've proven what I've wanted to, and I've shown each side is congruent, so I know that I have a correct proof. Now, this last one is one that you guys are going to basically have in your homework. And you might notice that this is going to be kind of hard to work with. And the reason why it's hard to work with is because nothing's labeled. You don't really want to be like, well, the top left angle, that is not the top center angle, is congruent to the top other. It gets a mess, okay? So make it easy on yourself. If the only thing that you're missing is labels, add some labels to your picture. Labels are one of those things that we can just write in. You can assume that whoever is reading your proof has the same picture that you have drawn in front of them, which is why a lot of times your proofs are set up next to the picture or corresponding to a number that I give you in the book, so the picture is already drawn. So here I would still have, like this angle given, like BAC is congruent to DCA. I could still do that for one of my givens. And I just treat this as if those had been drawn in by the person who gave me the picture. And that's what you are going to have to do on your homework. So in your homework that you guys did on Friday, you guys were given a bunch of different angles. Sorry, I meant a whole bunch of triangles, and you proved congruency for them. I want you guys to do that officially using those tables that we just saw, and do that for 2, 3, 4, and 6. And notice I just went through and labeled them myself. That is due tomorrow. Let me know if you have any questions. Have a good night.